Hello, everyone. Thank you for joining. Today, I'm going to talk about how to control the formation of disinfection byproducts, nitrosodimethylamine and bromate ions uh, using online monitoring technologies. These two disinfection byproducts are important to be monitored in potable water reuse, where the recycled water is transferred to the drinking water sources or directly to the drinking water treatment plant. At the advanced wastewater treatment plants, most of the plants have employed RO membrane-based systems where the secondary effluent is treated by microfiltration, reverse osmosis, and advanced oxidation processes. For cases where the RO concentrate cannot be discharged readily, like inlands, probably non-RO membrane system has been suggested as alternatives. So the secondary wastewater effluent will be treated by ozonation, BAC, ultrafiltration, and advanced oxidation processes. So non-RO membrane system is superior to RO membrane-based system in terms of the disinfection performance, but there are big concerns in the formation of disinfection byproducts. Among them, there are two important ones. The first one is called NDMA. That's formed by ozonation or chloramination. Notification level in California is 10 nanogram per liter. So this is a chemical. If you see there how much formation we have, so after the ozonation, the concentration really increases significantly. And BSC can remove part of that, but still could be higher than the notification level. Advanced oxidation process can also almost eliminate the NDMA, but the AOP is going to be really the single barrier for potable reuse now. The other one is the bromate ions. Probably everyone is aware of that. That's ozonation byproduct. Our contaminant level concentration is 10 microgram per liter. After the ozonations, if we pick up one of the studies there, so the concentration will be very high above the regulated levels, and then the BSC can remove it, but still we have to be careful with ozonation. The level of formation can change depending on the operating conditions, like precursor concentrations, temperature probably, but bear in mind that we really have to watch out how much bromate ions are formed. To enhance the safety or reliability of the recycled water for potable reuse, we suggest two monitoring technologies. One is NDMA analyzer, online NDMA analyzer. The other one is online bromate ion analyzers. So by installing these technologies, following the BSC, or could be the prior to BSC after ozonation. So over time, we could have our baseline as a normal value below the guideline values. And once we have a spike or peak of the concentrations, that's where the plant operators have to take actions. So either reducing the ozone dose or doses, or shut down the system, entire system like this. Today's presentation is about the validation in the lab. We have already finished the system developments earlier. In the future, we have to do the same validation on site for longer term, but today's topic presentation is really about validation in the lab. Actually, without ozonation as well, but we will see how the instruments are useful for the use of ozone as well. Let's talk about NDMA first. The challenges for the conventional techniques is they're very hard to make it online. For example, we pick up the conventional one here. It requires a large amount of volume, and it requires like manual work for pre-concentration. We have to add the surrogate as well. The recovery is not always high. And then the sample will go through expensive instruments. So it's not something we can make it online very easily. Something we can make it online, the best alternative is called HPLC-Photochemical Reaction-Chemiluminescence. It requires a very small sample volume, no pre-concentration step, so that we have a low detection limit, and it takes only up to 20 minutes. So this is a benchtop system originally. We'll talk about how we made online. The system is based on the mechanisms here. So NDMA separated by the HPLC will be irradiated of the UV, will have a UV irradiation, and the peroxynitrate will react with the luminol, and we get photon. Depending on the intensity of photons, we determine the concentration of NDMA. This figure shows the configurations of the system in details, but if you are interested in that, you may have a look at our previous paper. Orange County Water District has also validated that method based more for the benchtop style, and you may also have a look. I said that 20 minutes, it requires 20 minutes for analysis, and over 20 minutes, what you see in the system is something like this. So here is a peak of NDMA. So depending on the peak, the concentration will be determined. There are some other peaks over here. Some of them are nitrosamines one, and we could make it shorter, but because of their influence of these peaks, we try to make it longer, so 20 minutes. It could be 15 minutes as well. So we converted that system to an online system by installing a so-called 6-port valve, where we can change the sampling mode to the analysis mode, and we can preset the time, so that like every 20 minutes, the system takes a sample, and the system continuously runs. This is a result we demonstrated in the lab using actual wastewater. The first one is a ultrafiltration treated wastewater. It's still got a lot of color, the organics in water, but we used a bit high or quite high concentrations for NDMA, but their major objectives of this demonstration is really showing off that we can frequently monitor NDMA concentrations online. So this was successful in a way. We had an additional data set using RO treated wastewater. It's relatively clean, and we had a change in the operating conditions so that we have a change in the NDMA concentrations as well. But anyway, so we succeeded in analyzing NDMA online. That's what we did. Let's move on to the bromate ions now. Online bromate sensor. By the way, the NDMA analyzers, online NDMA analyzers, both the benchtop ones are present in Japan. Only 2 of them, and then I don't think that there are any of them outside of Japan. This is the same. In the world, there are 2 online bromate sensors exist. One of them is in my lab, and the other one is in another company, the Metawater. The sample volume is 400 ml, and no pre-concentration step. Detection limit is low enough, 1 microgram per liter, and it takes 90 minutes of time for analysis. This is really designed for online anyway. That system is based on this mechanism. So bromate ions reacts with TFP chemical, then we get the fluorescence. And depending on the intensity of fluorescence at these wavelengths, we determine the concentrations of bromate ions. What the system is doing is a bit complex, so I would skip this part. But anyway, major challenge we had was the presence of the interfering substances. So at the wavelengths 300, 400 nanometer, there is a strong peak even without doing anything. This is autofluorescence coming from the wastewater, organics in wastewater. So this is the humic acid-like substances. We have to remove that. This is a very strong as a background in the fluorescence. So we try to remove interfering substances by using nanofiltration membrane with a molecular weight of 300 gram per mole. So the most of their dissolved organics are larger than that, but bromate are smaller than the pore size. Then we can really purify the sample containing bromate ions. Then this is just showing off that we actually succeeded in removing the dissolved organics by using a nanofiltration membranes. Some operating parameters are actually very key to succeed, but I'll skip this part now for now. At the same time, we shouldn't remove the bromate ions. We should keep it in the sample, and the horizontal axis is showing the bromate ion concentrations in the permeate, and this is the NF vertical axis is showing their concentrations in the feed. So it removes a few percent of bromate ions, but there's still most of them are present after nanofiltration, so it's good to go. That's the results of the demonstration in the lab using actual wastewater, MBR treated wastewater. Over the course of 3 days, we had the online analysis. At the same time, we had periodically had the grab samplings for the analysis using the conventional techniques, LCMS-MS. We compared to show of the reliability of the analysis, even as an indicator, reliability is important. So this figure on the right-hand side, it's showing off the bromate ions in the permeate. The horizontal axis is showing the data using conventional ones, and the vertical one is the concentrations determined using the online system. So there are some variations, but basically it's got a high correlation between two, and that's probably good enough as an indicator. So a very short presentation today, but the take-home message. So as you saw during my presentation, and the online NDMA analyzer can provide NDMA concentrations every 20 minutes. Online bromate analyzers, that's important, coupled with NF membrane pretreatment. Without that, we get the error message, background interfering substances is too much. But anyway, that will give us the data every 10 to 20, 90 minutes. And the implication here is the spikes detected by the online analyzer can trigger an alarm so that the plant operators can take precautionary actions. So next steps, definitely we have to have a long-term, not few days, on-site, not in the lab, validation using a pilot scale ozone system. So today's presentations, I wasn't able to include the data using the actual ozone system, but hopefully in the very, very near future, we can present the data of the last part. Thank you for your attention.